Hi everyone, in this video I'd like to talk about how to find the area of a parallelogram formed by two vectors. And in this case I'm working with some vectors from a previous video. We had a negative 2u is a vector negative 6 comma negative 2, and the vector 3v was the vector 3 comma 6. And so I've drawn a little picture here. It's not to scale, it's not very perfect, but it just gives you an idea that I'm looking for the area of this parallelogram. And the way that we do that is we're going to find the magnitude. So I'm going to use the double bars for magnitude of the cross product, negative 2 cross 3v. Okay, so we're going to need to do a magnitude calculation at the end there. But first, let's talk about this cross product and how we're going to do that. Now, first of all, we're in two dimensions here. I'm only working with x and y, and cross product requires 3 dimensions. So I'm going to add in a bit of a fudge factor with a k component. So I'm still going to use my big bars for the magnitude, or maybe I'll write the word mag just so that we don't get a lot of things confused here. So I'm just going to write that I'm going to do the magnitude, and I'll do that at the end. I'm going to do the magnitude of the determinant. First row of my determinant is vector I, vector k, j, and vector k. And again, I know at the end I need to do a magnitude of that. Now, my first row there is going to be this vector, negative 2u. So that vector was negative 6, negative 2, and I'm just going to put in a 0 for the kth component. That's my z direction, or that third dimension. And since I haven't left my paper, there's no height off the paper, I'm just going to make it 0. And then 3v, that was the vector 3, 6, so we'll put that in here. And let's keep going. So now I need to do the magnitude of whatever I get when I do this determinant. So first trip through the determinant. I'm going to work on the first row, first column, so that's going to give me I times the determinant of what's left over, negative 2, 0, 6, 0. Next, I'm going to anchor myself here, first row, second column, so that's going to give me minus j because these determinants alternate in sign, and I've got negative 6, 0, 3, 0. And the last one, I'll anchor myself over here. So first row, third column, and now I'm just left with k, determinant of negative 6, negative 2, 3, 6. And close parenthesis on that magnitude calculation that I will not forget. So I need to do the magnitude of. Notice in here when I do my determinant calculation, I essentially have 0 minus 0. So nothing to report. Over here, same thing. When I multiply those diagonals, I get 0, nothing to report. The only interesting thing happening over here, and I should put little arrows over all my vectors if I want to be very precise with my notation. Those in. I've got negative 6 times 6. That gives me a negative 36 minus the other diagonal, and I get a negative 6. So minus a negative 6. Okay, so I need the magnitude. Well, at this point, I can go back to my double bar notation because if I had used double bars all along, we are going to have double bars and single bars for the determinant. It gets a little bit messy. Anyways, so I've got the double bars, and I'm looking at the magnitude, the vector magnitude of the vector in here, which is a k component vector, and it looks like negative 36 plus 6, so that would be 42k. And the magnitude of a vector we know is the square root of the x component, the y component, and the z component. Now, there's no sense in squaring 42 just to take the square root of it, right? We're just going to get the magnitude here is 42. And that would be my final answer for the area of that parallelogram. Now, there are other ways to do this. So you could go into your parallelogram here, and maybe you could break this up into two triangles. You know, or maybe you could do some sort of rectangle calculation, or, you know, there's different ways of doing this. You could have done maybe a right triangle up here, or trapezoid. So you could estimate your area, because you're working on graph paper, just as a double check with your cross product calculation.